Okay, today we're going to talk about percents, changing to fractions, changing to percents, using percents with probabilities, and using percents for a part of the total. Okay, now, what are percents based on? What number is the percents based on? So if you have all of something, you have what? 100%. So it's based on 100. Okay, the fractions that you have are based on 100. The percents you have are based on 100. Okay, so as we talk about changing a percent to a fraction, okay, first thing right here, percent changing to a fraction. Then what you're going to do is you're going to take the percent, whatever percent it is, okay, let's say you have 65%. And I want to change 65% to a fraction in simplest form. Okay, so I'm going to change 65% to a fraction in simplest form. What you're doing is this. You basically take 65 and multiply it by 1 over 100. Okay, now, most people say, well, you just put it over 100. That's true in a way. Okay, the problem you run into is when you get into more complex percents, and let's say you have 3 2/5%. Okay, well, then it becomes a little bit more difficult. It's not just putting it over 100. There's more steps involved. But basically, if you take the percent and multiply it by 1 over 100, that will always work. The other reason I like doing this is because that way I can cross-cancel. 5 goes into 65 how many times? 13 times. 5 goes into 100 how many times? 20. So I have 13 over 1 times 1 over 20. Okay, and that's basically just 13 over 20. Then I'm done. Okay, if you just put it 65 over 100, in other words, if I just take and put 65 over 100, well, then I have to divide by 5 to the top and bottom. 5 goes into 65 13 times. 5 goes into 100 20 times. It'll give me 13 over 20. Okay, that way works right now, but it won't. It's a little bit more difficult if we start dealing with mixed numbered or even decimal fractions. Okay, or decimal percents. Okay, so 13 over 20. You can't leave it as 65 over 100, Haley. That's talking to the one that was, doing her salon. Okay, so let's look at another one. Yeah, because the percents are based on 100. Everything you're going to do from reducing them, whatever, is always going to be based on that 100. So if I have this, if I have 88%, okay, well, I just said 88 over 1 times 1 over 100. You cross-cancel. 4 goes into 88 22 times. 4 goes into 100 25 times. And so that gives me 22 times 1 on top, 1 times 25 on bottom, for 22 over 25. That's not a point. It's a multiplication sign. So 22 over 25. No, I divided 4 into them. That's not what you said. Copeland, don't laugh. All right. So, fairly simplistic in that area. Now let's look at changing fractions to percents. Okay. Here they're going to use equivalent fractions for changing to a percent. There's another way called the proportion method, okay, that we'll talk about in the next section. This way that we're fixing to talk to you about only works with denominators that will go into 100. So, for example, if you had 7 over 12, this way will not work if you have 7 over 12. It only works by numbers that you can divide evenly into 100, okay? The proportion method that we'll learn in the next section works on every type of fraction. But like I said, we'll talk about it at, I think it's the next section or the third section. But for right now, we're going to talk about changing ones, for example, 3 over 25. And I want to change that to a percent. Okay? Well, what we're going to do that is we're going to make a fraction, an equivalent fraction, with 100 on the bottom of it. Okay? So what did we do to 25 to make it 100?
4.
Multiplied by 4. So therefore, we're going to do the same thing to the top, which makes 12. Now, 12 over 100 is not a percent, but all the percents are based on 100. So if we have 12 over 100, that is 12%. All right. So, like I said, all of the fractions you're going to be dealing with in this section, you can multiply something by the denominator and get 100. For example, we have 17 over 20. Okay? So we want to make a fraction with 100 on bottom. So you multiply it here by 5. So we're going to do the same thing, the top, multiply that by 5. Whoa. And get 85 over 100, which is 85%. Okay. Now, let's talk about them. Let's talk about percents and fractions with word problems. Okay? For example, number 24 says, you buy ice cream that contains 10% milk fat. What fraction of the ice cream is milk fat? What fraction of the milk is what? 1/10. Huh? What's 10 over 100 reduced? So 10% is 10 over 100, but you've got to reduce that. So that reduces to 1/10. Okay. It says currency. The composition of it, this number 25. The composition of a U.S. dollar bill is 3/4 cotton and 1/4 linen. What percent of the dollar bill is cotton? How did you get 75%, Josh?
3 over 4 plus 1 over 4 equals 1 whole.
Right.
And then just take away 1 fourth. 3 over 4, and then that's... I just know. I don't know how to explain it. I don't know how to work it out. I just knew.
Well, bottom line is you just have to take 3/4 and make it a percent.
Oh, no. 3/4 is 75 because they...
Yeah.
How? I'm so slow.
What? Haley, what?
I'm confused.
How did I do what?
You don't even start it.
Huh?
Never mind.
No, what are you doing? What?
I just don't get how you did that.
Well, the problem says that 3/4 is cotton. Okay? 1/4 is linen. 3/4 is a fraction. Means I got to take 3 over 4 and make it over 100. 25 times 4 is 100. So 3 times 25 is 75, which is 75%. So if this is 75%, then that would have to be 25%. And so they want to know how much of it was cotton, which is 75%. The other thing is this. If you look at the top of page 330, those are some common percents and their fractional equivalents. For example, 1/10, 10%, 1/4, 25%, 3/10, 30%, 2/5, 40%, 1/2, 50%, 3/5, 60%, 70% is 7 over 10, 80% would be 4 over 5, okay? And then 90% is obviously 9 over 10. So, it's good to have those memorized, then you don't have to change them. And a lot of the ones you're going to be dealing with today are just common percents that, like I said, easily go into 25. Now, number 26 says a football player completes 19 of his 25 passes during the season. It'd be more like a game, but 19 of his 25 passes during the season, what percent of his passes did the player complete? Okay.
So 19%.
No. They're giving you a fraction. 19 out of 25. Right. 19 over 25, and then you make it into a percent by making an equivalent fraction over 100. So Copeland, what'd you get? Yes, 76%. So you take 19 over 25, and you make it into a fraction with 100 on the bottom. Make it what? Once it has a percent, but you've got to change it to this first, which gives us 76 over 100, which is 76%. No, they just want, it says, what percent of his passes did the player complete? That would be the percent. Okay? We just did it. It's right there on the screen. I didn't circle anything? 76? All right, now, let's look at number 28. Number 28 says a computer randomly generates an integer from 1 to 10. Integers meaning counting numbers. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? It says find the probability of the given event, write your answer as a percent. So you have the numbers. Okay? That's the numbers that the computer is randomly going to generate. They want to know the probability that the computer generates a 5. So the probability that it's going to be a 5, what is the probability that it's going to spit out a 5 when it spits out a number? What, Gracie? 1 over 10. So there's 10 possible outcomes. One of them is favorable. So it is equal to 1 over 10, but they want that expressed as a percent. Well, we just said a while ago that 1/10 would be what percent? Yeah, 10%. So your answer is 10%. That's the probability that it's going to spit out a 55 when it generates that number. Huh? Hey, let the college guy teach. Let the people that can't finish their homework be quiet. How many numbers are up there? 5 or 10. Okay. How many number 5s are in those numbers? 1 over 10. Okay. So remember, probability equals favorable outcomes over total outcomes. Okay. So if we look at number 33, number 33 says, what is the probability that he's going to spit out a prime number? What is the probability it's going to spit out a prime number? Well, first of all, how many prime numbers are in 1 through 10? 4?
4 over 10. No. 5.
Name them. Stop. 1's not prime. 1's neither prime or composite, remember? Prime have to have 2 factors. Huh? It's a number, but it's not a prime number because it only has 1 factor itself. So there's 4 factors. So that's 4 over 10. So it'd be 40%. Because you take that, put it over 100, that'd be times 10, times 10, be 40. 40 over 100 is equal to 40%. Now, so that's dealing with it when it's a probability. Now let's look at it as a percent as part of the total. Okay, in other words, this, 75% of 12. Okay, so I'm going to go in the store and I'm going to pay 25%. They're having a sale 25% off. So that means if it's regularly 100% of the price, now I'm going to pay 25% less. That means I'm going to pay 75% of $12. Okay? The word of means what? What? Multiply. So that means we're going to multiply 75% times 12. Now, to manipulate a percent, okay, listen to me. To manipulate a percent, you have to change it to a fraction or decimal first. You can't just take 75% and multiply it. Okay, if you do, you're going to get a large figure that's wrong. So I'm going to take it and put 75 over 100, and I'm going to multiply it by 12 over 1. Okay, now we can cross cancel here. Okay, let's see, 4 will go into both of them, so 4 goes into 12 3 times, 4 goes into 100 25 times. Okay, and that's 3 times 75 would be 225 over 25. I could have reduced that further, but I'm going to do it like this. 25 goes into 225 9 times. So it would be, the new number is 9. So if you're paying 75% of the full price, $12, then you'd pay $9 for it. No, because it's not. I'm just using it in those. And so like if I had 40% of 170, or 175 actually. So that would be 40 over 100 times 175 over 1. Cross cancel, 25 into 100 goes 4 times. 25 into 75 goes 7 times. Now I have, and I want you to see this, 40 over 4, this right here can reduce. to 10 over 1 times 7 over 1, which is 70. All right, so your homework, 7.1. Eight through 42. Okay, still got about 15 minutes left in class. I'll let you break into groups and you can work with each other if you'd like to. If you want to work by yourself, that's fine too. Okay, but work. If you use the 15 minutes wisely, you should get at least half of it done.